Hello, welcome to RC Video Reviews. Today we're taking a look at a brand new charger from HiTec. It's the RDX2 1600 Duo. 1600 Duo. That's supposed to be 1600 watts. And I've got a very complicated setup right out of the gate because we're going to hit it hard. We're just going to go after it. We're going to go right after the meat and potatoes of the issue. I do want to point out that this charger supports the external link to the AD380 discharger. So this is just basically a big old heat sink and load, so you can dump at a much higher amperage rate to your discharger, the external discharger. I also want to mention that this video is sponsored by HiTec. They sent me the charger for review, but as always, my opinions are my own, and I'm free to express my review as I see fit. So that's what we're going to do. And while we get started, let me talk a little bit about how this is going to work. So the first thing I'm going to do is just test it. And before I get into the testing, I want to show you some settings because I've been, kind of poking around at this, trying to understand, what I'm seeing in terms of results with my testing. But the first thing I want to do is show you that when you get into the system menu, you want to set that max input power all the way up. And I have it set to 1600 watts. So that's as high as it goes. So 1600 watts input power. Minimum input voltage. If you're not familiar with my battery bank system, I have two LiFePO 100 amp hour batteries in series. So it's 25 volts. And so I've got those in series and they're able, I've been living with these batteries for a couple of years now. So I'm very familiar with them and I know what kind of power they'll deliver. Here's my voltage chart. Right now, I'm at about 90%. I've got them about 90% peak. So 26.6 is the input. So I set the minimum to 23, which is actually kind of low for the LiFePOs. That puts it somewhere between 0 and 9%. So it puts we're not even going to get close to that capacity though. But I'm just pointing it out because you'll want to set that if you're using a DC, like a battery power source. You'll want to set that as your cutoff voltage to prevent the charger from running your input source too low. You can set the LCD backlight. I set mine to middle. That seems pretty decent for inside. If I'm outside in the sun, I might set it for something a little higher. The key press beep, set it to low. Anything higher than that was pretty annoying. The notify beep, same thing, low is good enough. Completion tone, I set mine to once. There are other options here like repeat. If you do repeat, it'll just keep beeping at you until you take action. And then the warning screen, I went ahead and turned that off because when you first power it up, it gives you this little warning. And if you don't turn that off, then it's going to give you that warning every time you turn it on. So let's see, in terms of the language, English, I think that's it for the systems or the preferences. You can also go into task parameters and set up a few timers to prevent like overcharge or discharge. So 240 minutes is fine. Good idea to set a max capacity. Like for example, if you're charging, like if your biggest capacity is 5,000 milliamp hours, you might want to set this for like 5,500, right? Just as a safety measure. Trickle charge, you can turn that on or off depending on your needs. Same with keep voltage. The book is actually not very, I shouldn't say not very, it doesn't describe what keep voltage is at all, and I haven't experimented with it yet to figure it out. So maybe sometime later I'll work on that, but I have a feeling the idea is that it will, if you leave a battery plugged in, I think and you let it sit for a little while, I think it'll recharge it again, but I'm not sure. I'm not sure about that one. So anyway, that's task parameters. And then there's a little battery meter in here if you want to check out your battery source. I don't know why it gives me that one in red. I've checked these with my Fluke and they're all in balance. So I don't know why that's in red. And I don't know why the resistance is in red up here either. It's not, again, not very descriptive. I'm not sure if you're supposed to hit play and do a test or what. It's just not very clear. It looks like it's doing a little bit of a test when I hit the button. But anyway, there we go. We'll get out of that. You can reboot it to factory settings or reset it to factory settings. Here's one thing I tried out, the user guide. And because this is a brand new product, I'm going to make the assumption that the reason it does this, so I'm going to put my phone in here and let you guys see what happens when I scan the QR code. I think what's going to happen is, there it goes. It loads up the HiTec website. It does not go to an actual product for the RDX2 1600. My guess is it's because they haven't put the page up yet. That's my guess. But there is a QR code if you want to get more information or a user guide. So I'm kind of hoping they update that URL so that we can go use our phones and go get the manual that way. I think it's really cool that they're doing stuff like this. So I give them props for that. Okay. So then system info, this is where you can get hardware version and firmware version. And notice on my hardware version, I'm 0.01, so this is a pre-production. They might fix a few things before it goes live, but I guess we'll see. And then some regulatory information if you're interested in such things. And then I think that's probably it. Yeah, that's the systems menu. Now, interesting thing about the system menu, I'm kind of used to long pressing the jog dial like that and holding it and then getting into the system menu, but on this charger, you don't. You actually get into the charge settings. So what and again, I don't recall seeing it in the manual. Maybe I just set the manual down, or the quick. I shouldn't call it a manual. I should call it a quick start guide. But I set the quick start guide down, and I just started fiddling around with it. What I learned is that if you just press any two buttons together and hold them, that gets you into the system menu. So it doesn't matter which ones. Like but one of them has to be the jog wheel. I think. Let's try it. I think if you hold these two red ones, no, one of them has to be the jog dial. So it doesn't matter which two you hold, it just has to be the jog dial and something else, and that gets you into the system menu. Okay. Next on the right-hand side, interesting little development here. I asked about this expressly. I said, this has got an output power supply, and it goes up to like 1100 watts. So you can see I've got it set for 29 volts and 8 amps. I was doing a little testing earlier. I'll show you that in a little while. We'll get to that. But very interesting on the power supply. And I asked, why so much power on the output side? Because normally it's like, it's meant to be testing servos and stuff like that. And they said, well, if you're a racer, like you're an off-road electric or, nitro or whatever, you might want to power things like a tire warmer. And so having a little bit of power on the side here is not a bad thing. The other thing that I would mention, and, the first thing that my head went to was, if I go to the field for a day and I bring this charger, which by the way, it's a beefy charger. I'm going to show you dimensions later when I unplug all this stuff. We'll get into the size of it, but it is a beefy charger. But I thought, there's two ports. You could also pair it with something like this. You could bring an RDX2 800 and plug it in right on the side or the back right here, and you get two more ports out of the deal, which is not a terrible idea, right? So just keep that in mind. You got output power on the side. It's actually a DC power supply. Of course, you could also split your cable if you wanted to. That's certainly another option. But, what the heck? It's something novel. Okay, so let's get into the meat and potatoes of things. What I've got on the table, I want to explain the connectivity here. I've got a parallel board with 5 6L5000s, all from China Hobby Line, the only batteries I use these days. And what that'll allow me to do is I'm going to charge these at 2C. So you got 5 batteries, right? At 5 amps is 1C, and times 5, that's 25, right? So we could do 25 amps and have 1C on these 5 batteries. If we do 2C, that's 50 amps, which conveniently happens to be the limit of the charger when you're in parallel mode. I also want to point out what parallel mode means. Notice that on the charger, I've got this parallel harness that HiTec sent me, by the way. So it's parallel charging cord connected to my balance board. Okay, so that's why it's a little more complex than normal, because we're going to charge in parallel mode. And then the balance lead from the parallel board goes into port A. Okay, so that's the parallel setup right there. So two leads into the mains. There's A, there's B. Okay, let's put that up so you can see it better. So there's A. Come on, cables. They're not going to work with me, are they? There's A and there's B. There we go. So there's B on the right, A on the left, balance charger or balance port on the left. And then I also want to point out, this is an 8S charger. We'll charge an 8S battery just to show that it does it, but it's 8S on both sides. And if you want to monitor temperature for each one, you can buy an optional temperature probe. That's not included with the kit, but you can buy those. You can get a temperature probe and plug that in. And then there's a system setting in there that lets you keep an eye on temperature. So if you want to do that, that's good. Okay, so that's it. Let's run a charge. So again, the battery, the source that I'm using for this source is easily able to put out 100 amps, and it's been tested thoroughly, so no problems there. So what I'm going to do is go into the charge settings, and I've got LiPo selected. I've got 6S selected. The task is parallel, okay? And what that means is we're using the parallel, both ports to output power, okay? So it's a parallel charge. And I'm going to set it for 4.2 volts. normally, just as a point of record, when I'm flying my production packs, I normally use 4.18, just so you guys know. You get a lot of extra life out of your batteries by doing that, if you didn't know that. So yeah, 4.2 is the normal. You know, if you're looking for every bit of performance you can get, then 4.2 makes sense. But if you want to preserve your batteries so they last a little longer, consider 4.18. And then charge current, I've got that set to 50, which under parallel mode, that is the max. That's as high as I can go. All right. And then temperature cutoff. Remember the probes I told you about? If you want to use those, you can set a temperature cutoff. And then that's it. We're going to hit start. And one thing I'm going to tell you right away on the menu, you can scroll through, you just use the wheel and you can scroll and see what's going on. Actually, hold on. I did that wrong. You can scroll between port A and USB by pushing the wheel down. And then you can scroll through the different battery bits of information by pressing the port button, A again. So you can see we've got about 1,080 watts, 45 amps, 45.8, and 23.5 volts. So let's check their math real quick. I like to check their math. So we've got 23.54 times 45.63. That's 1,074 watts. Now, this is supposed to be a 1,600 watt charger. I configured it for 50 amps, which is supported in parallel mode, and I'm only getting 44. So I'm not sure why I'm not seeing 50 amps, but that means we're falling short on our output wattage by 600 watts. Let's be graceful about it and give them 500 watts. Okay, so what happens if we did 23.61 times 50? That's 1180. So in order to get the full wattage of 1600, you need like 30 volts on here. So 1600 divided by 50 amps, that's the peak. That means you got to be able to go up to 32 volts, which means 7 or 8 cell, right? 8 cell. 4.2 times. No, 4.2 times. Yeah, it's 4.2 times 8. That's 32. So you need to hit it pretty hard with 6S to get all the way up there. But I should be seeing more than that because it says 50 amps and I'm not hitting 50 amps. And it's not a question of input power. I know that for a fact. It's not that. It's not the input setting. I set it for 1,600 watts. So I think they need to work on that a little bit. Now, let's check the current. I'm going to bring up a current meter. I'm going to set it, and we'll grab this line right here and set it. So that's showing me 32 amps on that line, which is interesting. I'm not sure why. I'll put it on my main line. And on my main line, we're seeing 47 amps. So kind of close on the power draw coming in. But what the meter is showing me is 45 amps. So I kind of like to see that hit 50, and I'd like to see that jump up to the max. Now, let's do, if we're near peak, let's calculate that. 4.2 times 6, that's 25.2 times, let's see, 44.48. That's about where it is right at that moment. That'd give us 1,120 watts, which is still a little low, right? But if we did 25.2 times 50, which is where it should be, that'd get us about 1,260 watts. So yeah, not sure what's up with that. I think that should be fixed. It should give me 50 amps. There's no reason it shouldn't do it. So I'm not sure. I've been fiddling with this for a while and I haven't figured it out. Okay, so that's the charge. Now, it also supports AC charging on the back. The AC charger is good for 500 watts. So I didn't even bother testing it because frankly, I don't care. I'm sure that if we're hitting 1,100 watts, DC, that it'll do 500 watts AC. So I have no concern about that. That's why I didn't bother testing it. Okay. Next thing I want to show you real quick is I'm going to take it out of parallel mode, which means I'm just going to drop this connection from port B, and that's now out of parallel mode. And the next thing I'm going to do is run the discharger. So we're going to do an external discharge, and I'll talk about this rev dish in a little bit, but we're going to do external discharge, and let's see. It knows all by itself that there's an external there's an external load on there. So it should give me like 40 amps. Yeah, there it is. So 40 amps, and that's all due to this AD380. Okay. So I'm going to hit start on that. And when I do, now one thing before I do, I want to point something out because it's a bug that I noticed. You notice how this is sitting here at 23.38 right now? And I'm sure that's where the batteries are. Like, I'm positive of that. So it's holding at 23.38, which is where the batteries are. But so, okay, we're going to go ahead and hit start. And you'll see it automatically. It's going into discharge mode, and this is going to start climbing. You see the amperage over here? That's what I like about this. You can control your discharge from your charger, and the load, the 8380 takes up the load. So we're running 16 amps. I asked for 40. It's giving me 16. But keep in mind, it's a wattage question on this. So 380 watts, it's an 8380. So that math makes sense to me, right? Because we're hitting the wattage limit of the discharger. All right, so just understand, 380 watt discharger, 380 watt load. It doesn't really matter what you ask for in terms of amperage. But by setting it to 40, you'll get the max amperage it can sustain given the voltage, volts times amps formula. So in other words, it'll keep it pegged at its max discharge rate. Okay. All right, enough of that. This device is known to work quite well. I use this on a regular basis, so and this review isn't really about that. I just wanted to show you that it does support the AD380. Okay. Now what I want to do is I'm going to simplify things a little bit. I'm going to get rid of this mess because we've proven everything I need to prove with this mess. All right. This is my demand or my load to test the full input power, but I don't really need this anymore. So I'm going to unplug this and unplug this, and I'm going to set this all aside. And I'm going to show you a few other tricks that this device has up its sleeve. But before I do, I'm going to start by taking a look at what's going on here. It's another bug that I found. So watch what happens as the voltage creeps down on this screen. Nothing is plugged in except the input power. And the input power is about 26.4 volts. But notice how it jumped back up. It jumped really high. And watch it. I was kind of distracted, but watch what happens. It's going to drop fast, and then it's going to burst back up to something like 30-something volts, 38 volts. Watch it. And this device, the 8380, has an input limit of 30 volts. So it's overvolting it all by itself for some reason. See? There it went. And this will jump back up again. But look at that, 33.34 volts. What the heck is that? It overvolted. Now, I thought, well, maybe it's the 8380 doesn't understand the protocol, right? That's what I thought initially. So let's verify it. I'm going to bring my meter. I've got to put a different probe in, but I'm going to put the meter on here. And remember, this is a Fluke. This is a Fluke 87.5. This is a good meter. And I'm going to put this in here. And I'm going to put the other one on the side. And I'm going to try not to cross these leads because that would be catastrophic. Okay, 39.8 volts. I can't explain why. First off, I only have 26 volts coming in. So it's amping up the voltage. It's only 26 volts coming in. It's jumping the voltage up to 40 volts. And then you're supposed to plug that into a device that's only good. Here, let's look. I'm gonna disconnect this because I don't want to get zapped. Well, it doesn't say it on the device. But it's only 30 volts. I looked. It's only 30 volts. I was looking for something on here that would say what the input voltage is, but it's not there. But it's 30 volts. So I'm really not sure what the deal is with that. And just, because some people say try rebooting it. All right, fine. We'll reboot it. There it is. Unplugged, replugged. And I'll just put my meter on here again so you guys can see it. So check that out. Look, it's going to crawl all the way down, and look at that. It's going to wait for it. It'll crawl back up again. And by the way, I really don't know why it's showing any voltage here at all. It should be 0. There it is. You see it? Look at that. 38 volts. What the hell? That's a bug. That shouldn't do that. I hope they can give us a firmware update to solve that, but that's not okay. Okay. All right, so that's that. Now the other thing I'll show you. This is what one of the things I found really strange about it. I got to keep my meter in the picture. All right. So I'm going to go ahead and plug in. Now, we're reading 0 right now, right? And when I put these probes, it's sitting there at 0. Let's put the probes back in. Okay, so I'm seeing 39 on my meter, and I'm seeing 0 here. That's good. You know, that's a good thing. So now what I'm going to do is I'm going to plug it back in to the 8380. I'm only showing you guys this because this 8380 is part of the ecosystem. It's a HiTec product, and it works fine on the other chargers I have. Like, it works really good on this little RDX2 800. I don't see that kind of behavior at all. So I'm going to plug this in, and now you'll see, for some reason, we get a voltage reading. Now, maybe, I don't know, maybe it's coming from this device in. I'm not sure. But watch this. When I take this main and plug it in, that's it. It stabilizes, and this stabilizes. So no more jumping around. I don't get constant input voltage exceeded alerts on the 8380. It just stabilizes based on the pack voltage. So again, just kind of strange. It's a weird behavior. They need to fix that. Okay. Next thing I want to do is we're gonna use the little. I'm gonna slide all this. Okay, I think we can get rid of the discharger. Let's do that. That'll make a little more room on the desk. We'll set this aside. Okay. Now we're gonna move this over, and I'm gonna move this little RDX2 800 into the picture. And what I want to show you here is that on the side, I'm sorry about the glare, but in order to see it, there's a little bit of light there. What I want to show you is the power supply configuration and setup. So basically, this little this little 3-line button is the menu settings where you can go in and select what you want. So let's just say for voltage, I want, I don't know, who cares, 28 volts. We'll do 28 volts. And for amperage, we'll do, I don't know, let's just do 8. Can we do 10? Yeah, it'll do 10. Let's do 10 amps. Okay. And oops, there we go, 10 amps. And then we hit menu again, and we'll long press the play button. And when we do that, we go into CV mode, constant voltage mode. Okay. Now let's see what's going on over here. So if I bring my meter in and turn on turn it on DC and plug in my probes. All right, we got 28 volts, and I asked for 28 volts. So that's good. I'm happy with that. That looks really good. And then there's also, notice, a second one. So there's a second one. I thought maybe there was an ability to set 2 different outputs, but no, it's the same. So whatever you set on this screen, that's going to go out both of these leads. Okay. All right. Now what we'll do is we're going to plug in the little, I told you could kind of use this as a, an expansion pack, I guess would be a way to look at it. So there's a little RDX2 800. And what I'll do is I'll just take this little 4000 that I plugged in, and we'll move it over here. And by the way, I have a gripe to log too. When you get used to a charger, you're used to all the leads going the same way. Well, they flipped them. So on this one, the ground is this on this side. It's the inboard side. And on this one, ground is on the left side for both of them. So on this one, they're both on the right. So why not be consistent? Why not always have the same thing? That way when I'm using your products, I don't worry about plugging stuff in backwards. Okay, so there's the charger. There's the RDX2 800. I'm going to press play. We're going to set it at 4.2 volts. We'll use a charge current of 5 amps. I asked for 10. Let's see if it'll do 10. This is only a 4,000 milliamp hour battery, but it'll be fine to charge it a little higher than 2C for a few seconds. And then we'll hit, whoops, I meant to hit, instead of back, I meant to hit start. Okay. Startup failure, cell error. That's interesting. And it's on. I definitely see that it's on. So I'm not sure what that is. It's not happy about that. Now, here's the thing. I saw that earlier. I saw that in my testing earlier. So I got out this one, this little iCharger. So iCharger X6. And I'm going to plug that in. So I saw that before, not every time. I didn't see it every time, but I did see it. We're still on. The power supply, if you can't see it due to the glare, I apologize. But it's still on. It's still showing me, and obviously it powered up. So let's try that again. And I'm going to run a, let me change the amperage a little bit. We'll do the same thing. We'll ask for 10 amps. Okay. And then we'll start. And this little charger had no gripes at all. And by the way, yep, I'm hitting 10 amps. It's right there. So I know the glare is really tough. There. 10 amps. So the power supply does it. I don't know why this charger griped about it. I really don't understand it. I initially thought, well, maybe I did some damage to this, so I plugged a battery in the back and it charged another battery just fine. So that I can't explain. I don't have an answer. I don't know why. It works fine on this one. No problem. It's still hitting, still sitting there at 10 amps. No problem. And it's charging the battery. So the power supply works. I can't answer as to why this one is not happy being on that power supply. So there you go. All right, we'll stop that and we'll disconnect it. Now, I'm going to show you some other things too. I'm not done. I'm not done. We're not even close to, no, we're close. But here is something else I wanted to show you. Okay. Now, what I've got here, the best thing that I found in my stash to create a load is a little iPad. This is just an iPad Air. And there's a PD. You can see right there, it says PD 3.0, 20 watts. Okay. PD 3.0, 20 watts. All right, fine. We're going to stick in a USB-C, and I've got a meter plugged in, and I'm going to plug in my iPad. And my iPad lit up, so you can see it wants to charge. And we're looking at, now we can, remember on this screen, you can press this and then slide down and see what's going on USB. So this iPad right now is at 62%. And so that means it'll max out the load on any charger that's giving it a charge. And I'm seeing 11.79 at 1.4 amps. This is saying 12.2 at 1.4. So there's a little bit of a disagreement on the voltage, but they're pretty close. And I'm seeing 18 watts over here. So on this one, I'm seeing 17.5 watts. So I'll give it to them. I'm not seeing, what I didn't see is unknown mode. So I don't see power delivery mode on here, and this does measure power delivery, but it's showing me unknown mode. But it is showing me, let me go back to that screen. It is showing me about 18 watts. So, I mean, that's pretty good. You know, it's an amp and a half at 12 volts feeding the iPad. So what I will say, the reason, you know, power delivery might be meaningful to you is if you have a laptop. So I can tell you that I plugged it into a laptop and it will charge the battery, but it won't do both. It won't run the battery and charge laptop. Sorry, it won't run the laptop and charge the battery simultaneously. It'll do one or the other. So just something to keep in mind. But I'd say it's very close to the spec. So 18 watts. They say it'll do 20, right? They say 20. It's right there. Let's take this out of the way. That says 20 watts right there, and they're giving 18. So I'll let them have that one. That's close enough. Close enough. Okay, now I wanted to show you something else. This is another. It's just a bug. It's kind of a nitpick. I mean, some people might say, John, you're asking too much of this stuff. But here, I wanted to point out before I do. On this one, there's also a PD 3.0 20 watts. So let's test it. I mean, you know, if this is supposed to work, right, what difference does it make where the power is coming from? This device should have no idea where the power is coming from, right? It doesn't know. It just knows it's DC. So I'm going to plug this in. And, whoops, I plugged it into the wrong thing. Hope I didn't blow it up. No, you can't blow it up. Okay. All right, so I plugged into the PD port here on the side on this little RDX2 800. Again, this is a review about this, but I'm just pointing it out. There's something going on here that's not right. Now I'm going to take that same iPad. I'm going to plug it in. The same iPad. I just plugged it in. And it's charging. You know, it's giving me the little charge indicator. Okay. And I'm seeing 0.2 amps at 28 volts, though, so that kind of makes sense. And there's the USB power, 12 volts, 0.7 amps. And this is still able to deliver 28 volts at 10 amps, which we saw with the battery. So 28 volts, 0.5 amps. Now we're delivering, now it's starting to crawl up there. So 17, maybe 18. Ooh, are we going to go higher? No, we're going to hover around 18. Now, the reason I showed you guys this is because multiple times charging other devices, it reset this charger. It's, of course, live stream, so it's not doing it. But look, we're getting close to that 20 watts, very close. So that's good. That's what I'd expect, right? Because we've got power in, and this device doesn't know anything about where that power is coming from. So it should just behave like it's connected to any other DC source. Okay, so that's good. I'm impressed with that because, like I said, last time I did it, it rebooted. I'm going to try the, oh, there it was. Look at that. Whoa, 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 whoa. Okay. There, we just let the smoke out of it for some reason. There it goes. And all I did was plug that power source into the back of that charger, and we just let the smoke out of it. Well, that's the end of that live stream. So I guess you guys are going to want to be careful. Be careful. That definitely should have worked. That definitely should have worked. Yeah, these are right. The cables are right. Yikes. Yeah, that's not great. That's not great, man. Woo. Well, that's that. That ends the live stream on the RDX2 1600. I'm pretty sure that's fried. I don't know if I want to plug that back in again or not. That's kind of scary what happened in there. I saw a lot of smoke. Yeah, that's not getting plugged back in. I'm going to have to go check the tape and make sure I didn't cross the wires. So I'm going to reserve judgment for that. You guys are going to want to back it up and make sure I didn't cross the wires. I don't think I did. If I did, that's 100% on me. If I didn't, then whoops, you know, I don't know what to make of that. But my point in sharing that with you was that when I put that B port on the back and then charged the device, this turned off. So I didn't think much of it because it just turned off. But yeah, I'm going to have to check the tape, man, and see if I hope I didn't cross the wires. If I did, you know, mea culpa, that's my fault, not their fault. So we can't blame them. But we'll see. We'll see what happens. Okay, real quick on the specs before I shut the video down. I told you I'd give you a little walk around the outside. So it's a big device. It's a big device. This has got PD3 on the outside, external discharge port for that connector that we talked about. 8S temperature probe, port A for mains, port B temperature probe, and 8S for the balance lead. And then on this side, you've got your power supply output. It does say output, so output, and then 1600 watts DC. And then there on the back, there's your AC. And look at that charring on that thing. Boy, that got... Something's not happy on that positive side, that's for sure. So we'll see. I'm going to check the tape. And what I would say, let me, aside from the incident, because again, it happened live, so it's not like I can stop and review my own video and edit it, right? So it's live. Aside from the incident, here are my comments about it. Number one, I think they've got a problem with their circuitry when you have a battery, when there's no battery connected and we're outputting 39 volts here. I really don't understand why that was the case. It shouldn't do that. Number two, when we plug in a battery, it stabilizes the voltage and the output voltage. That I kind of understand because you are going to use the external discharger. So, you know, it's got to read that voltage. So I kind of get that. Number three, the input power being set at 1600 and only seeing 45 amps instead of 50 and not delivering, you know, the 1100 or whatever it was, 1150, 1200 amps that I expected to see. I can't explain that. I really just don't know why that would have worked that way. Okay. The output power, I think it's fine, I guess, that they have two outputs that'll support the same voltage, depending on what you set on the screen. I guess that's okay. I thought the use case for that was a little odd myself, except in the scenario where you might say, yeah, I want to bring an extra charger and expand my charging capacity at the field. You know, that's one use case. But outside of that, I guess, you know, it's okay. It doesn't really. Oh, and there was one other feature that I wanted to show you too, and because I'm not going to plug power in anymore, I can't. But it was called the reverse discharge. And the way that worked, the idea behind that was, let's say you're at the field and you have a large battery. You have any battery. It doesn't matter. It doesn't matter. It's big, small. It's immaterial. But let's just say, for argument's sake, you had a big battery you're not going to fly, you know, like for your helicopter, your jet or something, and you're not going to fly it, but you got a couple smaller packs, you know, for an airplane you want to fly. In that scenario, you can plug one battery into A and the balance lead, and then the other battery into B along with the balance lead. And when you do that, you can set it for reverse discharge mode and configure your low voltage and current that you'll allow off the source battery. And then you continue on to the second battery here, and you can set the charge rate, you know, the number of cells and the current that you want to draw for the second battery. And then when you hit go, the power goes from battery A into battery B. So rather than, you know, charge unnecessarily or, you know, tax the AC system or your DC power supply or whatever you're using, if you're just going to, you know, and by the way, you could use that as a discharge feature as well. Like if you know you're not going to fly the big pack, right? You're going to fly a small pack. Rather than just discharge it and convert it to heat and waste the energy, you can move that energy from one battery to the other. I did test that. It did work, seemed to be effective, but I don't know. It's kind of like a green thing. So anyway, that's it. I guess the only other complaint I have after I check the tape is if it blows up while you're using it, that's not great. So I'll go back and watch the video myself. I'll leave a comment and I'll say whether or not I did it wrong. And again, I just have to reiterate, in fairness to HiTec, if I cross the wires, that's definitely my fault, not the fault of the chargers. So we simply cannot hold that against HiTec. However, if I did plug it in right, then I would say maybe wait for these to hit the market. And I'll certainly be talking to HiTec about what I experienced if I did not cross the wire and change the polarity, which I don't think I did. But in case I did, I'll talk to HiTec about it. All right, guys, thanks for tuning in on the video. I hope you learned something here, and I hope you appreciate this kind of content. And if you do, I'd ask for a thumbs up, hit the subscribe button, and hit the notification bell so you know when new videos hit the channel. That's all I've got for today. Take it easy and get out there and fly something.